Hi, everyone. Thank you for joining us today on a very important discussion about the Arctic. The changes that are happening to our world as a result of climate change are visual and possible to see now. And before we get into the discussion of this amazing place, there's really no better way to see the impacts than to actually visualize and see them yourselves. So we're going to share with you a video that was created earlier this year for the Glacier Conference that Secretary Kerry hosted in Anchorage, Alaska. At that time, we brought together countries from all over the world to talk about this challenge, and this video was shared with everyone there. I also just want to note that the President has tasked the Arctic Executive Steering Committee with running and coordinating all of our work across the federal government on this issue. So come experience this yourself. Here's a video that we showed at the conference.
The Arctic is warming twice as fast as anywhere else on Earth. Its seemingly remote location in the north might lead some to believe that what happens in the Arctic stays in the Arctic. But that is not the case. The consequences of this region's transformation are being felt by the entire world, not just the Arctic's 4 million people. And the most important action that we can take to slow Arctic warming over the long term is to substantially reduce our emissions of carbon dioxide, methane, and other greenhouse gases. But it's also important to address black carbon, and that's the soot that's produced by dirty vehicles, oil and gas wells, and wildfires, and is a strong contributor to global warming by itself. But additionally, when this soot settles on the Arctic snow and ice, it increases the amount of heat that is absorbed, which in turn melts the snow and ice faster. Now, as the snow and ice melt, the darker land and water underneath the snow are uncovered and absorb more heat. This accelerates additional melting in the Arctic. In scientific terms, this is a positive feedback loop, and it explains why the Arctic is warming faster than anywhere else on Earth. The water from melting ice ends up in the ocean and contributes to sea level rise. Glaciers that have endured since the last ice age are shrinking and adding to the rising sea levels that threaten coastal communities around the globe. An emerging science suggests that changes in the Arctic may be affecting the jet stream in the northern hemisphere, disrupting weather patterns far beyond the Arctic. Now, Arctic communities are facing the full brunt of these changes. Thawing permafrost is destroying infrastructure. Loss of sea ice has left communities vulnerable to coastal erosion and threatens the survival of a number of key species. These communities are losing the ecosystems they depend on for their survival and the centuries-old traditions they've built around them. The good news is that we can do something about it now. Low-carbon solutions are increasingly abundant and affordable. Around the globe, the price of solar and wind energy has plummeted in recent years, with more than half of new power generation in 2014 alone coming from renewable sources. And some firms are voluntarily eliminating flaring and methane leaks from their oil and gas operations. Science has informed the public and policymakers about this environmental crisis. What is needed now is the initiative and courage to confront the problem head on. Our actions can protect or unravel the Arctic. Concerted and deliberate action by the world's leaders in politics, in industry, and in science will be needed to prevent the loss of our Arctic heritage and reduce further damage to the climate system. The responsibility for dealing with this challenge is on all of us.
It's been our mantra for a little while now. Paris isn't the end of the road. There's more work to be done. So I just want to reflect a little bit on that trip that the president took. It was quite a moving experience. It's not often that the president of the United States gets to spend 3 days in one location talking about one topic. But the Arctic is such a moving place, and it is such an incredible visualization of the problem of climate change that it was important that he brought the United States press with him, and he brought all of us up to that area to experience it ourselves and really see the impact and what's happening to the community there and what people are struggling through. And he heard emotional stories from the Alaskan natives that live there. One woman talked about the fact that she goes to bed at night concerned that her house could be swept away through if there's a major storm in the night and she wasn't aware it was coming. So these are the stories, these are the pictures, these are the experiences that we know are starting to change the tide of public opinion in the United States, and people are understanding that these impacts are happening now. So the two experts that you're about to hear from are going to talk a little bit about what's happening, the science of what's happening in the Arctic, really the phenomenon of why it's warming twice as fast as any other place in the world. And these are the experts, premier experts on this issue in the United States and around the world. So first you're going to hear from Assistant to the President on Science, Technology, and Director of the White House Office of Science and Technology Policy, Dr. John Holdren, one of my favorite scientists in the world. And we will also hear from NASA research scientist, Dr. Patrick Taylor, who has extensive experience studying the Earth's systems through observations and climate models. But with that, without further ado, I'd like to welcome Dr. Holdren.
Well, thank you very much, Christy. We're just going to elaborate a little bit on the key messages that you already saw in that video, and start by emphasizing why do we focus so much on climate change in the Arctic? And the answer to that question is, first of all, as already has been noted, the climate is changing more rapidly in the Arctic than anywhere else on Earth, with conspicuous impacts of a magnitude that compels recognition of the reality and the urgency of the global climate change challenge, as well as the need for immediate assistance to the populations, above all the indigenous populations that are being affected up there on what you might call the leading edge of climate change. And the other point, which has again already been noted in the video, is that rapid climate change in the Arctic is creating influences on climate outside the Arctic, notably accelerating the rise of temperature globally and affecting atmospheric circulation patterns in the northern hemisphere in consequential ways. In other words, as the title of this session indicates, what is happening in the Arctic is not staying in the Arctic. So I want to summarize very quickly what we know about those changes, both inside and outside the Arctic, inside and outside the region. First, inside, temperature, sea ice, land ice, the glaciers and ice sheets, permafrost, and wildfires, and then outside the region effects of the wildfires, of the greenhouse gas emissions from the Arctic, and the circulation patterns. And starting with temperature, it's already been noted that the average surface air temperature in the Arctic is going up twice as fast as the global average, but in some parts of the Arctic, it's 3 to 4 times as fast as the global average. One of the consequences of that has been shrinkage of the sea ice, about which Dr. Taylor will say more shortly, but the short message is that the area of Arctic sea ice in late summer has recently been about 40% smaller than it was as recently as the late 1970s, and the volume of that sea ice is down by even more. And open water instead of ice means bigger waves and loss of shoreline protection, leading to coastal erosion and damage, even evacuation for coastal settlements, and that, of course, is made worse over the long run by sea level rise. Open water instead of ice also means feeding, breeding, and survival challenges for seals, walruses, whales, polar bears, impacting, of course, subsistence hunting. And more ocean, more open water instead of ice means more absorption of incident sunlight, thus increased heating and accelerated further temperature increase in the Arctic. Turning to land ice, most mountain and coastal glaciers across the Arctic are shrinking. That increases river discharge and turbidity. That in turn affects erosion and potentially fisheries in the ocean as well as in rivers. Alaska's glaciers alone are losing 50 to 75 billion tons of ice annually. The Greenland ice sheet is experiencing extensive surface melting in summer, as well as acceleration of the flow of major coastal glaciers to the sea. Water on the surface of the ice increases absorption of sunlight and thus leads to even more melting. The total loss of ice from Greenland has been averaging 250 to 350 billion tons annually, which is up 4 times in the last 2 decades. Thawing permafrost. A high proportion of land in the Arctic and the subarctic is in the permafrost region. For the state of Alaska, the proportion is 80% of the land is in permafrost. And as soil temperature rises along with air temperature, the upper layers of permafrost in the warmer regions start to thaw. This is happening over much of the permafrost region. The impacts of thawing permafrost include land subsidence, threatening buildings, roads, and energy infrastructure, increased vulnerability to coastal erosion and wildfires, and exposure of previously frozen soil carbon to being released as carbon dioxide and methane. Expanding wildfires, higher temperatures, drier landscapes, trees killed by insect infestations, and more lightning, all related to climate change, mean more, bigger, hotter wildfires. The combined acreage burned in wildfires in 2015 in Siberia, Canada, and Alaska, just by the end of August, was over 31 million acres. In Alaska, the annual number of large wildfires has doubled since the 1980s, and the average annual area burned has quadrupled. Wildfires, of course, destroy valuable timber and habitat. They create massive smoke pollution. They directly add large quantities of carbon dioxide to the atmosphere, and they expose soil carbon to microbial action, producing even more CO2, and of course, they contribute to the thawing of permafrost. In the Arctic, for the first time, we are seeing not only trees burning, not only forest fires, we are seeing the tundra burning. Tundra fires for the first time in the Arctic. Turning to the last of the local effects, changing ocean chemistry. In addition to reduced salinity and increased turbidity as a result of increased discharge to the ocean of glacial fresh water, the Arctic Ocean, like the rest of the global ocean, is becoming more acidic. And acidification in the ocean is intensified in the Arctic by the combination of low temperature and low salinity that prevails there. The effects of those changes include impacts of acidification on marine organisms that make their shells or skeletons out of calcium carbonate. The interaction of salinity changes with changes in temperature affect ocean circulation, and the impacts of all of that together on marine fisheries, with consequences unknown but still potentially very severe, are affecting and potentially will affect commercial fisheries, sport fisheries, and subsistence fisheries. So let me turn for just a moment to the impact of climate change in the Arctic, beyond the Arctic. Those wider impacts include, surprisingly, impacts on human health as well as visibility, sunlight reaching the ground, and atmospheric heating from the long-distance transport of smoke from the Arctic wildfires. That smoke transport reaches outside the Arctic and has big effects there. The regional changes outside the Arctic include changes in the Northern Hemisphere circulation patterns. That was suggested also in the video. Blocking highs, slowdown and waviness in the jet stream, bringing polar vortex phenomena into the mid-latitudes, again because of faster warming in the Arctic. Globally, of course, we are seeing the acceleration of global sea level rise as glaciers and the Greenland ice sheet lose ice as a result of warming. It goes into the ocean, again as noted in the video. And we are seeing increased release of carbon dioxide and methane from microbial action on organic carbon that previously was frozen in permafrost, in addition to methane from thawing methane hydrates in soils and sediments. This has the potential to accelerate warming all across the world. What can we do about this together? The remedial actions, of course, include mitigation, agreeing upon and committing to ambitious national targets for emission reductions, being discussed, of course, at this meeting. working together across national, state and provincial, local and tribal governments, the private sector, academia, and civil society to identify and deploy cleaner, more efficient technologies for energy supply and use. It includes working together on preparedness, resilience, and adaptation, including making available the data and information on best practices and financing to help communities, businesses, and individuals reduce their vulnerability. And it includes research, improving understanding of the challenges and the opportunities around climate change in the Arctic through data sharing and cooperative research on improved technologies for energy supply and use, and on the climatic, ecological, and socioeconomic processes that are shaping climate change in the Arctic, its impact, and society's responses. And finally, we can and we must collaborate on geographically denser, more comprehensive, more continuous measurement and monitoring of Arctic climate change and its impacts. And with that, I'm going to turn to Dr. Patrick Taylor, who will have some very exciting graphical information to share with you. Dr. Taylor.
Thank you, Christy. Thank you, Christy, for the introduction, and thank you, Dr. Holdren, for laying out so clearly an overview of Arctic science as well as the true challenges that we face. My desire to understand the climate system really started with my love of clouds and wanting to know what really made the climate system tick. Now, through my scientific training, as well as my work at NASA, I've come to appreciate that climate science is more than just a fun hobby. It's actually something that we need in society to help move us forward. So I'd first like to show you how unique the spaced view of Earth really is. So this is a picture you've likely never seen before. This is a picture of the moon going in front of the sun, but it's from 1,000,000 miles away. So we're seeing the dark side of the moon, a vantage that we would never get from our ground-based perspective. This is just one example of the beautiful but also extremely useful perspective that we get from Earth from space. I like to think of the climate system as a gigantic puzzle, where all the pieces are the atmosphere, the oceans, the ice, the land, the plants, the animals, and also we can't forget humans. We're a very important part of the climate system. No single satellite can potentially measure all of those different puzzle pieces. NASA has a fleet of Earth-observing satellites, more than half of which involve international collaborations, and the remainder of those involve agency collaborations within the US. Additionally, going forward, there's no way that any single country could potentially measure all of the different pieces of the puzzle. That is the climate system. So to move the climate science forward to the place that society needs it to be, international collaboration isn't really just a nice thing to do, it's something that we really need. One of the iconic images, in my view, of the rapid and unprecedented changes that we're seeing in the Arctic climate system is of the changes in the sea ice. This is a picture that we have from satellites beginning in 1979 through the present day of the changes in the sea ice extent. The white colors here are showing you the actual area of the sea ice coverage in any given year in September of that year. The yellow line in front is showing you the total area integrated average. What we see in this time frame as we move towards present day in 2014, we've lost on the order of 3 million square kilometers of Arctic sea ice over this time. To put that into perspective, that's the same land area as the 2nd through the 8th ranked European countries in terms of land area. That is Ukraine, France, Spain, Germany, Norway, Sweden, and Finland all combined together. For a USA example, that is the same area as Alaska, Texas, California, and Montana combined. Now, it's not quite a fair comparison in terms of numbers, since Alaska has 3 times the square footage of France, so it's a pretty big state. So in the Arctic, we're not only seeing all of this change in sea ice, land ice is melting as well, as Dr. Holdren referred to. This really unprecedented data series of the Arctic ice loss, or the land ice mass that we see over Greenland has been enabled through a very unique satellite called GRACE. GRACE stands for the Gravity, Recovery, and Climate Experiment, and it's a collaboration between NASA and the German Space Agency. What we're monitoring here are the changes in the mass of the ice sheets. The blue colors are showing you places where we've gained ice, which are happening a little bit in the interior. But as you can see, the very strong red colors, Greenland is literally thinning and disappearing at its edges. I term this the Great Greenland Weight Loss, I like to refer to it as. But in this case, the biggest loser is society. So I would like to take a quick moment to explain to you how GRACE works, because I think it's one of the really cool satellite missions that NASA does. It's actually twin satellites. The two satellites, they kind of chase each other in orbit. They're separated by a distance of 220 kilometers. And they're measuring directly Earth's gravity field, which is influenced by the changes in the ice mass. There are minuscule changes that you really wouldn't be able to see with the human eye that happen as the satellites are affected by Earth's gravitational field. NASA is able to measure the distance between those satellites extremely accurately to better than 10 microns. To put that into perspective for you, 10 microns is about the width of a human hair. So this unprecedented data set is giving us brand new views of the Greenland. So again, as Dr. Holdren said, what happens in the Arctic doesn't stay there. This roughly 320 billion tons of water that is coming off of the Arctic land flows into the ocean every year, and it's influencing sea level rise globally. This is a data set that began 22 years ago through a collaboration between NASA, NOAA, as well as the French space agency CNES. It is a high-resolution picture of the changes over the last 22 years of sea level rise. What you see, the areas that are shown in red are showing you places where seas have gone up. The blue areas are showing you places where seas have gone down. So we've seen some very significant regional variability in sea level. Sea level doesn't rise, hasn't risen everywhere. The global sea level rise that we've seen in this 22 years is about 8 centimeters or order of 3 inches at a rate of 3 millimeters per year, which you probably have heard before. Well, you notice these regional changes in sea level rise are due to two factors. One, changes in wind circulation, the water being pushed around differently by the winds, and secondly, because of warming of the sea surface temperatures. Warmer sea surface temperatures, the water takes up more space, and therefore higher sea levels. What happens in the Arctic definitely does not stay there, and one very critical component of the climate system that I like to refer to as our circulatory system is one of the key reasons why. These white arrows that are shown here are surface currents, water flowing at the surface. The grayish colors here are showing you water flowing at depth. As the first image there, the first arrows were showing you the movement of water in the Gulf Stream, from the tropics towards the North Atlantic. As that water moves towards the north, it becomes saltier and it becomes a little bit colder. That means it sinks in the North Atlantic. That's a very critical component of the thermohaline circulation, which it's called. Again, I like to think of this as our circulatory system. It's a lot like how blood flows through our body. You know, the heart pumps, moving the blood through our veins, making sure the oxygen and nutrients are making sure they get everywhere and that our entire body is connected. The thermohaline circulation does a similar thing in that it moves water and energy around, making sure that every other climate region on Earth knows every other climate region. As we see, as it zooms out and showing you the thermohaline circulation for the entire globe, you see that these arrows don't just stretch from the tropics to the poles. They actually stretch from pole to pole, connecting every other climate region with every other climate region. In this image, this is an image of the polar jet stream. It's a fast region of moving airs that's above our head. You may have noticed this was shown in the video earlier. It's a fast-moving air, about 6 miles or 10 kilometers above our head. Speeds reach upwards of 100 miles per hour or 160 kilometers per hour. The red colors here are showing you regions of faster-moving winds, whereas the blue and green colors are showing you regions of slower-moving winds. As Dr. Holdren referred to, the changes in the Arctic are outpacing the changes of the rest of the globe. They're changing about twice as fast. Those temperature differences mean that the gradient in temperatures between the Arctic and the regions farther south are changing, and that is a critical constraint on how this atmospheric circulation system actually behaves. So as we warm the Arctic faster than the rest of the globe, this temperature gradient is changing, and this can lead to slower wind speeds and a more meandering jet. We have a very interesting case study of this possibility of how the Arctic can influence the rest of the globe. Just a few years ago in the United States, this was the winter where the polar vortex really became part of our vernacular. Okay? What happened that year is the winds slackened in December and January 2013 and 2014, causing very frigid Arctic air to no longer be trapped in the Arctic where it normally is. It escaped southward, causing record low temperatures for really the whole winter. But on a single day in January 6, 2014, more than 50 record low temperatures were recorded, stretching from Colorado to Alabama, the whole way up to New York. So in closing, I'd like to say that NASA, in collaboration with its US agency and international partners, are witnessing some unprecedented and rapid changes in the Arctic. Science is telling us that what happens in the Arctic won't stay there, whether it's through changes in the permafrost, as Dr. Holdren referred to, changes in sea level rise, or altering atmospheric and oceanic circulation patterns. These processes will make sure that what happens in the Arctic affects everyone. So as a climate scientist, as a husband, as a father, and as a citizen of planet Earth, we need to better understand Earth's climate system in order to help society sustain itself. So in order to do that, it requires a tremendous international collaboration, but in my view, it's within reach. So thanks.
Thank you, Dr. Holdren and Dr. Taylor, for really taking a complicated scientific situation and bringing us visualizations and a story that's tangible. I mean, I think part of the issue for a lot of us, certainly in the United States, is the problem seems far away. What I got to see when I traveled with the president up to the Arctic and to Alaska and Anchorage was a community of folks, Alaska natives, came to speak to the president about what they're experiencing. And what each one of them shared was a story about the complications of what they're facing as they experience this science right at their front door. It really is ground zero for the changes of climate change that are happening around the world. And what we're trying to do from Washington, D.C. and the United States is figure out the policies that can address these problems and really listen to the people of the Arctic and of our citizens there of what they need. There has in the past been a bit of a top-down notion that we're just going to tell people in these communities that this is what they need to do in order to survive a challenge like this. Well, that's not how it works when it comes to climate change. And we're seeing this all the time with our resilient policies. We need to hear from the community, hear about what they need, and listen to their leaders. And so one of the things that we're hoping to do is help coordinate conversations with the Alaska Natives, with the leaders on the ground who have determined that possibly their communities may have to move. This is another place where potentially the policies of the Arctic may not stay in the Arctic, because we will see communities across the world that will address this issue of whether or not they have to move, which is so emotional. Certainly when you're talking about a community like Alaska Natives who are so tied to the land, their sustainable way of living, their fishing and hunting rights and everything that they've been able to establish in that community, the idea that they would have to uproot their entire village to move someplace else is very traumatic. So how do you work through that conversation? How do you work with the leaders on the ground and figure out how you address it in the right way? These are conversations, difficult conversations that have started around the world, and we know what we learn from the Arctic and what we're learning in other parts of the world, we may be able to share as more and more folks address this very difficult question of how their communities are going to either relocate or figure out how to adapt and be more resilient to the changes that are impacting their communities. After the president's trip, we all have a long list of to-dos. It was a trip where the request to us was, please don't make this just a one-day trip. Please go back, synthesize what you've learned, and figure out how we take this out through the rest of the administration. So each of the stories that the president heard, what he said to us was, you need to figure out how we really make a change and have a lasting impact for these communities. So that's part of the conversations we're having now. You can see he was truly moved and touched by what he heard from the communities there. It is a different place than the lower 48. No roads in a lot of locations. The idea that the tundra would be burning, as Dr. Holdren mentioned, is just unfathomable. And I actually spoke to two women, Alaska Natives, earlier today who were talking about the fact that it is raining in the Arctic in December, which is unheard of for them and really creates a whole host of problems for how they're going to hunt and travel across their communities to really sustain their way of life for the rest of the year. So complicated problems, but for us in the United States, really supporting our communities that are in the Arctic is a huge responsibility and something we think we'll be able to share with the rest of the world as we learn how to do that. So now we would like to turn to some questions because I think there's a lot we can learn from this and certainly having our experts share a little bit more on this topic. The first question may seem, more of just an expansion on what we talked about originally, but I'm wondering if both of you could just talk to us a little bit more about why we're seeing this 2-degree increase in temperature or the 2 times warming in the Arctic compared to the rest of the Earth. Really just give us a better sense of that.
Sure, I'll take a start at that. The key point is that ice and snow reflect most of the sunlight that hits them back into space. And so not much of that energy is left to warm the surface environment. Open water is much less reflective than ice, and bare earth is much less reflective than snow. So when you get some initial heating that reduces the area of ice on the ocean and reduces the area of snow on the land, that initial heating, because of the reduced reflectivity of that surface area that's no longer covered by ice or no longer covered by snow, leads to more heating, more loss of ice and snow, and so it's self-reinforcing. This is what scientists call a positive feedback, and it's not called positive because it's good for us. It's called positive because an initial disturbance tends to be amplified and become a bigger disturbance.
It's an excellent, Dr. Holdren. I can only really add to that by we have a visualization over here that can kind of, this is really a picture that shows exactly what Dr. Holdren was saying, where we have the solar radiation that's coming in. It's being reflected by the brighter ice, less reflection happening off the darker ocean. But as we melt the ice back, more of that solar radiation is being absorbed by the ocean, by the darker ocean, accelerating, causing further warming. I've personally done some research in this area using climate models, and the models are telling us that this feedback isn't just important recently, it's going to continue to be important and continue the acceleration of the warming in the Arctic for the next century.
Dr. Taylor, can you talk a little bit about tipping points? I mean, there's a lot of science to unpack here, but where are the points we think that we really tip into a different reality?
Well, I have, there's one example that we have been showing this week here, we have some great imagery for, and that is, here's a picture from the Landsat series of satellites that shows the Columbia Glacier, which is located in southeast Alaska. This is the bluish, the light blue and cyan colors here are showing the glacier retreat. Since 1986, the glacier has retreated more than 12 kilometers, or about 9 miles. However, in this case, we don't think climate change has really caused all the melting of the glacier. In fact, what happened was climate change gave this glacier an initial nudge, and then natural processes kind of took over and caused the rest of the melting. It's kind of like if you're standing on the top of a hill and you give a ball a small kick, gravity takes it the rest of the way. So in this case, climate change melted the glacier just a little bit, putting it into an unstable regime, and then the other processes that we know about took it the rest of the way.
Also, Dr. Holdren, certainly the melting of the ice up in the Arctic is creating new challenges when it comes to shipping lanes, when it comes to impacts on mammals in that area. Can you talk about international coordination and how that's beginning and going on?
Sure. The 8 nations that own territory in the Arctic formed, starting in 1996, the Arctic Council, the 8-nation Arctic Council, which has built up collaboration on such questions as navigation, marine fisheries, search and rescue, and also science. An important thrust of the Arctic Council is improving scientific measurement and scientific cooperation in the Arctic. The United States happens to be in the chair of the Arctic Council. It rotates in 2-year terms. We happen to be in the chair now, and we're giving particular emphasis to the science, as well as to the plight of indigenous people and how we can help them, and as well, of course, to safety, freedom of navigation in the Arctic. We have in existence already an international Arctic system for observing the atmosphere, which is a collaboration of meteorological stations around the Arctic to help scientists conduct coordinated research and understand in a coherent way what's going on up there. The European Union has an institution called INTERACT, which is the International Network for Terrestrial Research and Monitoring in the Arctic. It has a station in every Arctic country and every Arctic ecosystem type. So there's a lot going on to build up understanding of what's happening up there, but we need to do a lot more.
Great. So we would like to give you all of you an opportunity to ask questions on this topic. So I know I'm not sure I prefaced saying that, so I'll give you a minute to think about it. And Dr. Holdren, I'm going to put you on the spot. If you can just expand a little bit on coordinating across the federal government with so many agencies, and how really being in the chair of the Arctic Council and also your position in the Arctic Executive Steering Committee, what you're seeing in terms of how we're bringing everybody together.
Well, thank you for that softball, Christy. President Obama in January of this year created by executive order the Arctic Executive Steering Committee, which brings together the more than 20 cabinet departments and agencies that have activities and responsibilities in the Arctic. I'm the chairman of the Arctic Executive Steering Committee. Amy Pope, who's the assistant to the president, Deputy Assistant to the President for Homeland Security, is the vice chair. The committee is populated by the deputy secretaries of every cabinet department with interest in the Arctic, and that's most of them, as well as the heads of the various relevant agencies, NOAA, NASA, the National Science Foundation, the Coast Guard, and so on. And it has primarily 4 responsibilities. One responsibility is to synchronize priorities in the Arctic across all of those departments and agencies. A second is to coordinate and oversee implementation of those priorities in an organized way. The third priority is to improve communication between the U.S. federal government and the state government of Alaska and the indigenous tribal leaders across Alaska, so that the federal government is speaking with one voice rather than with 24 or 25 voices about how we are working and should be working with the state of Alaska and with those native communities. And the fourth function is to support the U.S. chairmanship of the 8-Nation Arctic Council in its international activities to bring a coherent approach to these challenges in the Arctic.
Okay, Tom has the microphone, so please raise your hand if you have any questions.
I will take a couple questions at once, get a whole range. I do want to say hello to some high school students in New Jersey who are watching us right now. And if you're online, remember you get your questions asked on Twitter using the hashtag AskUSCenter. So I'll take 1, 2, and 3. How about we do the 3 in the front?
Thank you. Your opening video featured black carbon as part of the problem. Black carbon is not covered by the FCCC because it's a particulate matter, not a gas. The Arctic Council is rather weak as a regulatory agency. The International Maritime Organization is slow, and the CCAC is interested in black carbon in other areas. So it seems to be there's a gap in really acting on the black carbon problem. And I wonder if you have any ideas, any possibilities, any specific government policies or plans to act on the Arctic black carbon problem. Thank you.
Yeah, we certainly have been working on that. The United States government produced a report from the EPA not long ago on the challenges of black carbon. We are working on it within the 8-Nation Arctic Council. One of the saving graces, perhaps, is that soot, black carbon, is also a serious health hazard, a direct health impact in the areas where it's being emitted. And as a consequence of that, there is a very substantial incentive for the nations involved to clean up their own black carbon emissions just on the grounds of public health. And we're trying to build on that to get that problem under control.
Okay. Thank you for the wonderful show. I have a particular climatological question. You told us that the warming of the Arctic might push down cooler air. And I wonder if that's a good news, because it might cool down lower latitudes. Could you elaborate on that, please?
Well, it doesn't push down cool air consistently, is the problem. What really seems to be happening is, as was noted in the video and I noted briefly, the jet stream, because of the reduced temperature difference between the Arctic and the mid-latitudes, is getting weaker. The jet stream is driven by that temperature difference. When the Arctic warms faster than the mid-latitudes, the temperature difference shrinks, the jet stream weakens, it becomes wavier, and those waves in the jet stream allow lobes of cold air, particularly in the winter, to come south, and lobes of warm air from the south to go north. And so you have this almost paradoxical situation where the northeastern United States is unusually cold while Alaska is unusually warm. And while there's still some controversy about exactly how these mechanisms work and how natural variability is interacting with the human influence, I think it's highly likely that we're going to see more of that. But again, it's not a consistent pattern where you're going to see the lower latitudes cooling in a way that offsets the warming associated with the greenhouse gases. I don't know, Patrick, if you want to amplify on that.
So I'll say that changes in the temperature difference between the Arctic and regions farther south, we expect that to definitely have an influence on how the atmospheric air, how the circulation patterns will behave in the future. As Dr. Holdren referred to, exactly what's going to happen, we don't know, but we do expect larger variability is likely due to the more meandering jet. The year of the polar vortex, 2013-2014, as Dr. Holdren referred to, some of those regions in the Arctic actually were very warm. The monthly average temperatures were, in some regions, were 5 to 10 degrees Fahrenheit warmer than normal. So bringing cold air down moves warm air into the Arctic, which it influences the climate change in the Arctic as well. So what we know for sure, and the science is telling us, is that changing this equator to pole temperature gradient will change the atmospheric circulation, but it's an area of active research to know exactly how that's going to manifest itself in the climate system.
All right, thanks for that. We'll take two questions here, one here in the front, and I thought the one here in the back too. So.
And there's a web question. You mind if I
great.
add that?
Go for it.
Great. So let me do the web question first. Kristen at Lorax Lee asks, is the more dramatic change in Arctic Ocean acidity the result of colder water allowing greater absorption of CO2?
It is partly due to that, and it is partly due to the lower salinity, which actually enables acidification to proceed more rapidly. And the lower salinity is coming from the melting of the glaciers and the land ice in Greenland, which is adding fresh water, diluting the salt.
Okay, thank you very much for your presentation. I'm Luca Lombroso from University of Modena, Reggio Emilia, Italy. Two short questions. One about permafrost methane release and the risk of big feedback. And one about if you have evidence about impact of jet stream change in Europe. For example, in Modena, in the northern Italy, on February 2012, during a big snowfall, was colder than Svalbard Island.
I'm not sure I understood the second question, which I think was asking us to elaborate on these patterns of cold and warm.
If you have evidence of impact of jet stream change in Europe.
Yes, there is evidence of that,
okay.
and a growing literature on that phenomenon. And on the feedback issues, the question, I think, of whether increased emissions of carbon dioxide and methane from the Arctic are going to have a big effect. One of the things that we know is that the amount of carbon stored in the soils of the far north is 2 to 3 times the amount of carbon that's now in the atmosphere. And the principal argument is how rapidly could that come out as the Arctic warms? Nobody knows the answer for sure, but certainly the potential is there for a significant acceleration of global warming, particularly if a lot of it comes out as methane, which of course is a much more potent greenhouse gas per molecule than carbon dioxide.
I would say with respect to the permafrost, I would say that You know, in 1997, the International Permafrost Association put together this nice map, a feat of real tremendous feat of international collaboration in order to really map out the permafrost. And recently, NASA actually digitized that map in order to have it in a more usable, readable format in order to move the science forward. And recently, the SMAP mission, the Soil Moisture Active Passive mission that was just launched in January, it was able to, for the first time, map some of the freezing and thawing patterns that happen in the Arctic over this past, the early spring and April. However, the radar on that instrument did fail, so it's much more difficult to map that going forward from this point. So I would say that there's definitely a need to have a very robust data set of permafrost and the spatial variability of it going forward so that we can improve our understanding of how the permafrost is going to change in the future, and so we can understand, you know, how much how much total carbon is in the permafrost and how rapidly we expect that to be released.
All right, we have two questions here, one back here and one to the far back.
Good afternoon, Reggie Jewel from Kotzebue, Alaska. It's good to see you.
Hey, Reggie. Good to see you.
A quick comment with regards to what happens in Alaska doesn't stay there. The trampoline was derived from the blanket toss, and you know the history of kayaking in the Olympics as well as trampolining. So that's two examples. The question I have is, with regards to some of the stuff that we saw, and you spoke about the melting ice and the opening of shipping lanes, how is the agency coordinating group taking a look at how the Arctic and people from the coastlines can develop some of the infrastructure to help be responsive in those areas, as well as the infrastructure that may be needed in terms of other things that are beneficial to the country?
All right, and hold on, before answering that question, I get one more question back here.
Hi, Quentin Zondervan from Cambridge, Massachusetts. It's my understanding that as the atmosphere warms up, it can hold more water vapor, and we know that water vapor is also a greenhouse gas. So do we understand how much that amplifies the warming and how much that will continue to amplify the warming going forward?
Yeah, let me take the second question first. Yes, we understand that very well. The water vapor feedback is a very important factor in determining the middle-of-the-road estimate of the sensitivity of the surface temperature of the Earth to changes in the greenhouse gas content of the atmosphere. The current estimate of that sensitivity, the best middle-of-the-road estimate, is about 3 degrees C per doubling of CO2, and it turns out that more than half of that is actually due to the water vapor feedback. So that is well understood. To Reggie Jewel's question, and I should say that Reggie Jewel was a member of the Council of State, Local, and Tribal Leaders helping the administration figure out how to respond to climate change. Reggie Jewel is the mayor of the North Arctic Borough in Alaska, which has an area the size of the state of Indiana with 30,000 people in it. And there are enormous challenges up there. And what is going on in the domain that Mayor Jewel mentioned is an intensified interaction between federal authorities, Alaskan authorities, and the native communities up there to figure out precisely how to build the kinds of infrastructure and to add the kinds of capacities that will enable those communities to benefit from those changes that provide opportunities and to cope with those changes that are posing challenges. We think that similar activities are going on in the other Arctic nations, and that's one of the things we are talking about in the Arctic Council, trying to propagate best practices with respect to the interaction of national and provincial governments with the native communities up there so that we can benefit from the opportunities and cope with the liabilities.
With respect to the water vapor feedback, Dr. Holdren hit it right on the head. Water vapor feedback more than doubles the initial response due to just warming of CO2 alone. I wanted to highlight quickly some very innovative scientists at NASA Goddard Research Center are mapping for the first time some of the changes in the Arctic moisture in particular. Because as we melt back the ice in the Arctic, you're uncovering more ocean. And we are finding signs of increase in the water vapor and in the moisture content of the Arctic atmosphere directly.
All right, I believe Ashley has another question from online.
From the web, yes. This is from Ms. B.D. Bondrake. And so it's from the high school students in New Jersey that Tom introduced. And they ask, what can they do to get involved with this Arctic issue?
That is a wonderful question. I just met yesterday at the U.S. Embassy downtown with a set of teachers of K through 12 schools around the country who have been exceptionally effective in expanding their programs on climate education. We have, in the Obama administration, launched a year ago a climate education and literacy initiative, the premise of which is basically that the kids are the future. And our kids learning about climate change, how it's happening, what its effects are, what the potential remedies are, is immensely important to the future of this issue. So I would say to kids in schools, including the young folks who asked that question, the first thing that kids can do is learn about this problem. The second thing they can do is persuade their parents, since political will is going to be important to establishing and maintaining the policies we need from our governments. But I can see that Christy is ready to add something on this.
Yes, so high schoolers in New Jersey, I think very much now what we're seeing coming out of this conference, we're talking to mayors, talking to governors, it's getting engaged and sharing your own passion on this issue. So if you are concerned about the Arctic, I mean, there has been a long history in the United States of communities who have talked about the wonderful wildlife there, the ecosystems, the importance of this special place to the entire United States. And I really think we have a responsibility, whether you're in high school or at other points, to share that story, to blog about it, to share pictures of the president's trip or other pictures that you find online about this amazing location. Because it can feel far away, it can feel disconnected if you're in the lower 48 states of the United States, but really what exists in the Arctic, whether you're talking about the caribou or any of the other amazing wildlife there, is truly unique, and it is an incredibly special location. So we need your help and everybody else's help to talk about that place and really share it with your friends and your family online and elsewhere so that people feel more connected to what's happening up there so we can have the political will to respond and protect the location for future generations.
What I would say is that I love working at NASA. And I love being a scientist. So I would encourage all those kids, learn about science. If you're really interested in it, go after it, major in college, because we need more people in the world that understand science, because I think it really helps society. So I really like what I do, so I encourage you to do it too.
All right, we have a couple of minutes left, so I can take a couple more questions. I see one here and one in the back.
Hi, Robert Gibson, Hong Kong. The potential release of permafrost or methane from permafrost in the Arctic could be enormous impact. What can be done to stabilize it, aside from stopping the increase in carbon dioxide in the atmosphere?
All right, and one more question back here.
Well, you want to take the question before I do the answer?
Yeah, we'll take the question and then answer both.
Hi, I'm from the Sami Parliament of Norway, and together with me, I have two people here who is also Sami people. They are representing the Sami Council, who is one of the 6 permanent participants in the Arctic Council who are indigenous peoples. And I have a question. How are you gonna communicate with the indigenous people the native people of Alaska when you develop new policy and stuff like that? In Norway, we have a system, a consultation agreement between the Sami Parliament and state authorities. And that works very well, and they are obligated to consultate with both the Sami Parliament and the direct group of Sami people who are affected of any new policy, legislation, or other things. Thank you.
Okay, very, very quickly on the first question, the single most important thing we can do to slow the problems arising from the thawing of permafrost is to slow our emissions worldwide to reduce the rate of temperature increase. It's very hard to intervene directly in any other way. And that's why the discussions at this COP-21 conference are so important. We really need the world to move together in concert to reduce those emissions, to reduce the driver. As to the question on the mechanisms for interaction with the indigenous peoples across the Arctic, again, we started to do that in the United States with the Council of State, Local, and Tribal Leaders that advised the U.S. government on what we need to do with respect to climate change, including in the Arctic and including in interaction with indigenous people. When President Obama went to Alaska for the Glacier Conference, there was a roundtable, I think Christy also participated in it, with Native American leaders from across the U.S. Arctic. That has led to a set of follow-up activities and to the expansion of our activities in the Arctic Executive Steering Committee aimed at improving the communication between the federal government and those communities. But again, it is also a theme of our chairmanship, the U.S. chairmanship of the Arctic Council, to share best practices across countries in terms of working with the indigenous people to address the particular challenges that they face.
One of the other announcements, just to add on to what Dr. Holdren just said, when the president was in Alaska, he announced we have a commission called the Denali Commission in Alaska that had a particular mission when it was first established. We're going to rework the mission of the Denali Commission, and a key component of that will be working with the Alaska Native community. I mean, consultation in the United States, we are working on that constantly. Consultation, consultation, consultation is what Secretary of the Interior Sally Jewel would tell you. It is far from perfect in the position we have with many of the tribes in the lower 48. Alaska is a slightly different situation than we have with some of the other tribes. So we are hoping that working through the Denali Commission and with partners like Mayor Jewel and others that we can improve upon what's been started. But it is an ongoing question, and I think something that we really do have to improve upon if we're going to get this right in terms of addressing what the communities need in the Arctic.
Well, NASA doesn't specifically deal with communicating with indigenous people, but I'd like to just quickly note that NASA's just kicked off an 8 to 10 year field campaign called the Arctic Boreal Vulnerability Experiment. And we're trying to understand exactly how environmental change in the Arctic is influencing both the ecosystems as well as how how that influences the human systems, and particularly how the human system can use those the ecosystem services. And as part of that, there is some outreach component of that. So hopefully we can connect with those folks who live in the region.
All right, thank you. We're out of time, but I do want to thank Christy Goldfuss, Dr. John Holdren, and Dr. Patrick Taylor for a fascinating look at the Arctic. With a round of applause.